the second part of this lesson is finding the angle of elevation. So what does it mean, angle of elevation? Well, this is the technical definition. It's a reference angle created by a horizontal and an elevated point. So it's something higher. So for example, if we had a little dude standing down here and he's looking up at a building or something, well, the horizontal would be here. So that's horizontal to him. And then if he's looking at the top up here, how far up is he going? That is the angle of elevation. So you see this in all kinds of things, like maybe a radar tracking a thunderstorm out here. You know, it's got lightning or whatever and rain. And so then your radar is tracking from a horizontal and an angle of elevation. So that, how far up, is really what you want to ask yourself when you're talking about angle of elevation. Now, angle of depression is how far down. So maybe you're talking, let's say that you got a building now, and you've got a little dude up here, and maybe now he's looking down. He's looking down on something down here, maybe a car or whatever. And the angle of depression is not the angle that he makes with the building. The angle of depression is from the horizontal down. So if he was looking straight ahead and then he looked and turned his head downward, this is the angle of depression. Now, here's the cool thing, that remember alternate interiors? Since we have a horizontal there and a horizontal here, this is the same degrees. So the angle of elevation from the car is the same as the angle of depression from the dude. So make a note of that they're equal, okay? So this would be the elevation angle, and this is the depression angle, but you got to be careful on how you draw your diagrams with that. So remember that when we start going into the next section. So in this practical application section, you're going to have a lot of word problems. And these word problems are, you're going to have to draw a diagram. So what I need you to do is draw diagrams every time. Draw diagrams. Okay, so if you can see the triangle, you can figure out what exactly they're looking for. Now, here's what this one says. A 12-meter flagpole casts a 9-meter shadow. So let me see. Let's make a flagpole. We'll make it blue. So we've got a flagpole here, and at the flagpole has a shadow that's cast out here, and it's wanting us to find the angle of elevation with the sun. So what that means is there's a sun up here somewhere, and it's casting down a shadow. So we're gonna have to find this shadow. Let me switch back to red for a second. So we're needing to find the angle of elevation right there. That's what it's wanting. What is this? Okay, so let's label. It says the flagpole is 12 meters and the shadow is 9 meters. So in order to find the angle of elevation, well, basically we can even draw this out of context. Now we have a 9, a 12, and a theta that we're looking for. Well, and that's super easy because we can use trig ratios. So from this, we've got the opposite, we have the adjacent, and so we're going to find the angle by using tangent, the inverse tangent, tangent -1 of the opposite over adjacent, 12 over 9. Okay, so tangent -1, 12 over 9, 53.13. So theta is equal to 53.13 degrees. Cool. So this is how you use the angle of elevation versus depression. But make sure you draw diagrams. That is the key. Draw a diagram with the information they give you, label it, and so you can figure out exactly what they're looking for.